Let's take a look at some of the combination factoring problems from section 2.6. And these problems start from part 9, and I will go over a few selected problems here. So from question 9a, I need to factor this polynomial expression. And just taking a look at this trinomial in the brackets, let's go ahead and factor that. So I need two numbers that multiply to 9, and those two numbers need to add to 3. So the two numbers that I'm thinking of are 3 and 3. So 3 times 3 is 9, and 3 plus 3 is 6. So if I go ahead and set up two brackets, I'll have x plus 3 and x plus 3. All right, so that's that part factored. And then we also have to take a look at this last part here, which I'm circling in red. So that will just tag along at the very end as 4y squared. Now if I take a look at this expression right here, I can rewrite that as x plus 3 all to the power 2 minus 4y squared. And now we can factor this using the difference of squares factoring technique. And when we're factoring by difference of squares, I need two brackets. There's a plus sign and a minus sign in the middle. And let's go ahead and take the square root of this last term because that one's a little bit easier. So the square root of 4y squared is 2y. So I need a 2y at the back end. And then let's go ahead and take the square root of x plus 3 all squared. And that's simply going to be x plus 3. And that's how you can factor question 9a. All right, let's move on to question 9b. All right, so for question 9b, let's start off with the trinomial inside the brackets. We need to factor that. Since I have a coefficient that's not 1, this is a 4. I have another 4 here, and I have an invisible 1 here. So I'll be using the smiley face factoring technique to break down that trinomial. All right, so I need two numbers that multiply to 4. So I'm thinking of 2 and 2. And I also need two numbers that multiply to 1. So I'm thinking of 1 and 1. And if I use the smiley face technique, 2 times 1 is 2, and 2 times 1 is 2, and 2 plus 2 gives you that 4. All right, so if I want to factor this, let me just kind of continue over here. So I have a little bit of space here. So two brackets. Okay, so let me use my green marker here. So here's a 2 and a 2. So I need a 2x and a 2x. And then this 2x multiplies onto this 1. So I need a plus 1y. And I also have another plus 1y here. All right, and then there's also this minus 9z squared that tags along. And then just like the previous problem, this 2x plus 1 times 2x plus 1, you can rewrite that as 2x plus y all to the power 2 minus 9z squared. And now you can use the difference of squares factoring technique because you have two terms, 1 and 2, and you also have a minus sign in the middle. All right, so for the difference of squares factoring technique, you need two sets of brackets. There's a plus sign and a minus sign. And just like my previous problem, I'm going to start on the tail end here, or the back end. So the square root of 9z squared is going to be 3z and 3z. And then you take the square root of the first term, and that's going to be 2x plus y, and this will be 2x plus y. And that's how you can factor question 9b. Okay, let's move on to letter C now, x to the power 8 minus 1. All right, so you need to recognize that there's two terms, 1 and 2, and there's a minus sign in the middle. So this is a difference of squares factoring problem. And for difference of squares, I right away put the plus and the minus sign in the middle. And then you're taking the square root of each term. So the square root of x to the power 8 is x to the power 4, x to the power 4, and the square root of 1 is 1 and 1. All right, so that's part 1. And you'll recognize that over here, the x plus 4, this is another difference of squares. So we can actually continue to factor that. So we will be using the difference of squares factoring technique on x to the power 4 minus 1. Remember, you have two terms, 1 and 2, and you have a minus sign in the middle. Whenever you have that, you know it's a difference of squares factoring problem. All right, so I need a plus sign and a minus sign in the middle. And then let's go ahead and take the square root of x to the power 4, which is x squared, and the square root of 1 is 1. So x squared plus 1 and x squared minus 1. Okay, and believe it or not, we can actually continue to factor more because we have another binomial here, x squared minus 1, where the middle sign is a minus sign. So that means we can further factor x squared minus 1. All right, so let's go ahead and copy out x to the power 4 plus 1 and x squared plus 1, and we can copy that part out. And then let's go ahead and continue factoring this part right here in pink. So for that, I need two sets of brackets, 1, 2, minus plus sign, minus sign, and then now we're taking the square root of x squared, which is x, and the square root of 1 is just 1 and 1. All right, so I had to apply the difference of squares factoring technique 2 times for question 9C, and this is our final answer right here. All right, let's move on to 9E. Okay, so for 9E, we're starting to get into some tricky problems where you need to be very comfortable with your power rules, or your exponent rules here. I noticed that we do have 2 terms, and we do have a minus sign in the middle, so right away I'm thinking that this is a difference of squares factoring problem, and I will put a plus sign and a minus sign in the middle to get started here. Okay, so one of the problems with this particular problem is that if I look at the 4 to the power 2m, I have 4 to the power 2m. So if I think about 4 to the power to 2m, that's really 4 to the power of, well, you're really adding m plus m, right? Because 2m is m plus m. And if I go back to my exponent rules, this is the same thing as 4 to the m times 4 to the m. Remember, if the bases are the same, you just add the powers. So what that means is this 4 to the m and that of the 4 and this 4 to the m right here, those two 4 to the m's, you need to have those at the front of your factoring expression here. So 4 to the m times 4 to the m. Because if you multiply that together, you get 4 to the power of 2m, which matches the first term. Okay? So you can't use the square root technique, which works for other problems, but this one we have the exponents need to be dealt with carefully, so we need to use some of our power rules or rules from the exponent chapter to kind of think about how that will work. All right, now using the same kind of argument, if I have x to the 2m, that means you should have a x here and an m there, and an x here and an m there. Okay, and then over here, the 9 to the 2n would be 9 to the n, and this y would be y to the n, and then you have a 9 to the n and a y to the n at the tail end there. Okay, so that's how you would factor question 9E. So we're not using any square root techniques here. We're just thinking about the powers here. Remember, if I multiply 9n and 9n, I get 9 to the power of n plus n, which is 9 to the 2n, and that matches that expression right there. Okay, so that's how you can kind of confirm by doing some FOIL to make sure that you get back to the original problem there. Okay, and letter F is a very similar problem as well. You'll notice that we have 2 terms and we have a minus sign in the middle. So this is a difference of squares factoring problem, and I'll put a plus sign there and a minus sign there. Now for this problem, I will take the square root of the last term here. So the square root of 1 is just 1, so I'll put a 1 there and a 1 there. Now this part right here, the 9 to the 4m, x to the 4m, well, we got to think about that again. Let's think about the 9 to the 4m. I mean, that's the same thing as 9 to the 2m plus 2m, because 2m plus 2m is 4m. And that's the same thing as 9 to the 2m times 9 to the 2m. Right? So remember, if the bases are the same, we just add the powers. So I can have a 9 to the 2m here and a 9 to the 2m there. And also for this x to the 4m, I can have an x to the 2m here and an x to the 2m there. All right, so that's part 1 of the factoring problem, and you'll notice that we have another case here in green where I can continue factoring and breaking that down. So let's go ahead and think about that while I recopy this first part down. X to the 2m, so 9 to the 2m times x to the 2m plus 1, and this is another difference of squares factoring problem, so I can put 2 brackets, a plus sign and a minus sign. The square root of 1 is just 1 and 1. And if I have a 9 to the 2m, that's the same thing as 9 to the m plus m, which is 9m times 9m. So I need a 9m here and a 9m there. And I also need an x to the m and a x to the m. And that's how you can factor that problem there. Okay, I think I have maybe 3 more factoring problems and then we're done this section here. For letter G here, let's go ahead and set up 2 brackets because this is indeed a difference of squares factoring problem. The square root of x to the 16 as x to the 4, actually not x to the 4, sorry, half of 16 is 8, so x to the power of 8 and x to the power of 8. And the square root of 256 is going to be 16, so I need a 16 there and a 16 there. All right, so the theme here is once you factor using a difference of squares, you have to look within your problem, see if you can continue factoring, which we can. So I have another difference of squares factoring problem here. Since there's a minus sign there, so let's have a plus and a minus sign, and let's go ahead and take the square root of these. So the square root of 16 is 4, and the square root of x to the 8 is x to the 4, so a 4 and x to the 4. And then you'll recognize that we can continue factoring over here again, so I need to recopy this 16 plus x to the 8, and this 4 plus x to the 4, and then I need 2 more brackets here, a plus sign and a minus sign, and the square root and the square root. 2 and 2, this will be x squared, and that will be an x squared. And believe it or not, we can continue factoring this last term there, that 2 minus x squared. That's another difference of squares factoring problem. So let's copy all this stuff one more time. So quite a bit in this last little problem here, and let's go ahead and set up 2 sets of brackets. I need a plus sign and a minus sign. Square root of that is going to be x and x, and believe it or not, the square root of 2 we can just leave as the root 2 and root 2, and that would be your final answer there. Okay, let's take a look at letter I. Now for letter I won't be using the difference of squares factoring technique. I'm just going to look within the problem and recognize that there's a trinomial, a perfect square trinomial there, and I have a kind of this binomial here which I can continue factoring here. So if I take a look at the last part, the 5x plus 10y, I can factor out the 5 and I get x plus 2y. So I'm just taking out a common factor there, which is 5. And then this part here, which I'm underlining in blue here, this is a perfect square trinomial, so 2 brackets. And I need 2 numbers that multiply to 4, and those 2 numbers need to add to 4. So that's going to be 2 and 2, right? So 2 times 2 is 4, and 2 plus 2 gives you the middle 4. So this would be x plus 2y and x plus 2y. Okay, and you'll recognize that this part is the same, and that's going to be x plus 2. Actually, from here, what I'll do is I recognize that there's an x plus 2y there, there's an x plus 2y there, so let's go ahead and factor that part out. So this part right here, we're going to factor that out as x plus 2y, and then if you look at this carefully, this part in yellow, the x plus 2y here, and this plus 5, those are the only things that remain, so I can recopy those parts down as x plus 2y, and then the plus 5 is at the very end here. Okay, so let's see if I can just explain that again. So this x plus 2y, that part is right here, and this plus 5 is right there, and the 2 green parts have been factored out over there, and this right here is your final answer there. So for that problem, I didn't really use any difference of squares factoring techniques. I just kind of looked at the whole problem and found 2 individual pieces where I can factor them using just general factoring techniques, and you can also arrive to this answer by doing that. Okay, let's go into letter K here. For letter K, I'll definitely use a difference of squares factoring technique somewhere in the problem. And I recognize that 9x squared minus 12xy plus 4y squared, I can definitely factor that using using some various techniques here. I'm thinking of 2 numbers that multiply to 9. I'm thinking about 3 and 3. And I'm looking at this 4 here. The numbers that multiply to 4, I'm thinking of 2 and 2. And since there's a minus sign in the middle, I'm going to have a minus sign here and a minus sign there. So if I use the smiley face technique here, 3 times negative 2 is negative 6, and 3 times negative 2 is negative 6. And if you combine negative 6 and negative 6, you do get this negative 12 there. So I can factor using the smiley face technique there, and I can consider this minus 16 at the very end. Okay, so if I go ahead and factor this, let me just use my green marker here. I have a 3 and a 3, so let's have a 3x here and a 3x here. And I have a -2 and a -2, so this one's not too hard to figure out. That's going to be -2y and a -2y. And then this -16 will tag along like that. Okay, and I can rewrite this now as 3x minus 2y all to the power 2 because those two terms are the same. And then I have a -16 at the very end here. And now I can apply the difference of squares factoring technique because I have two terms and I have a